Okay, so if you have questions, it's good time to actually input your questions now, okay?
I answered obviously what's happening at the interview.
Yeah, you got, yeah. Yeah.
I did all the time. Where does it say? I don't
It's all work for us. And there's like I was never an educator. My friend was showing me that board. It's like. It's probably 20. So I got it. Did we have a regular? So something like that.
This is like so much variety. Okay.
That's what my house is. I'm the kind of time they should live. It's a bigger picture. It's like get out there and get alive. Yeah, I think it's from where I done. Okay. And very tight, but I feel so And I got all mad. Big dog. You got food on your table. I think what's really those days. Like everything
Jenny, guys.
Okay, I want to actually get started. Okay, so let's start by answering some of the questions that you guys have. Where's my jacket? I guess it's so iconic, like I wear a jacket for many years. Okay, and then that's a jacket my wife picked for me. Okay, and you guys know I've been teaching this lecture for a couple years, right? So I guess that's very can recognize. Okay, let's actually start the chain by seeing my jacket. Okay, yeah. So I still wear this jacket. Okay, just in my office. So it is fine. I'm still going to wear it. Okay. So let's answer for your first questions. Second questions. Gosh, that's a tough one. I need to actually call my agent to contact her, but I don't know the schedule. All right, after I got it, I will let you know. Okay, how will the review be structured next week? So you guys see this hangout for the midterm one, right? So we're going to go through those questions. Those questions are the questions that related to the question we went through in the individual chapter hangout. Okay, so when we go through those questions, again, we are going to do the things we do all the time, right? Identify the keywords and then associate to a key question, knowing what equation to use. Those are the things we need to actually practice a lot so that you get familiar with this mode, then you will do well for your midterm. Okay? And then all the thing will happen in right here, okay, at the normal lecture time. I was strongly encouraged that you come, okay? Some people will say, okay, it's fine. I can actually go back home and watch the recordings. Yeah, that is actually one way, but I still feel like this in-person lecture allow you to just ask the question that you want to ask, right? So I think that's actually a lot more effective, right? Also, you got to see me wearing my orange jacket. I think that's actually a big plus as well. So why don't you do that? All right. Okay, next one. What are the most commonly missed concept questions on the exam that you recommend we should really focus on? Everybody's different, so it's hard to actually give you the answer. Okay, so the only thing I can say is actually if you know every single question I went through, you understand the logic, you can recognize the keyword, know the key equations, you are fine. Okay, so that's the things that I can actually promise. But those promises will be in vain if you do not really input your effort, input your time. There's no way I can actually really say, okay, you will actually get the score that you want. Okay, but if you really follow the model that I provide, I think you have a good chance to get a really good score for these specific courses. Okay, so I guess this is follow the same line. What are some tips to review the exam? Work closely with me. That is the tip. Okay. How will we know if we are sure ready for the exam? Okay, you have quiz, right? Okay, bring out your quiz. Okay, time yourself. Solve every single question within a minute, then you're fine. You can 100% sure you are ready for that. Okay, you see the questions, you know what equation you're going to use, you know how to do the calculation right. That's all you need, right? But How easy is that? It really depending on how familiar you are with this process that's looking for the keyword using the key equations, right? How robust you can actually operate your calculator, right? That's something that I cannot control, right? You are the one who need to actually push all those buttons and then give the numbers. Yeah, that is the part that you need to really get familiar with. Okay. Who do I have for the Super Bowl? That's a secret I'm not going to show you. Okay. Which formulas should we memorize? You only have 3 sheets. Everything I put on those 3 sheets are the things you need to memorize. Is that clear? Okay. Anything else you don't? In fact, we don't have much equation on the 3 sheets. Right. So I hope this will actually narrow down the things that you need to memorize. Okay. And then I guarantee you, many of you still will ask these questions next week. Okay, because not going to lie. Okay, whoever actually come to the lectures in person are the people. I guess up to this time, you are the people who somewhat trust me, right? And somehow you feel like, okay, the way I teach works for you. Okay, so I believe the one who actually sit in here is the one you probably will start to enjoy the benefit using the way I teach you. Okay, you can see how empty it is, right? Yeah, so let me say actually we have 300 kids here. Okay, here roughly we have 100. Okay, let me say actually 2/3 of the student is not going to really get those benefits yet, right? So many of students, I know everybody has your own situation. It is okay. Okay, and I also tell you that chemistry is not that important if you are not chemistry major. Okay, but one thing that's important is that remember on the first day I say what? I say you guys are adults. Right? I keep saying the same thing. Okay, you realize that okay, I'm going to say still the same thing at the end of this semester. I respect you as an adult. Okay, but are you truly an adult? You want to ask yourself. Okay, the reason I say that is because I expect everybody to be responsible for your own life. Okay, everybody has your own expectation for your life, right? Okay, I'm not the one who can actually be responsible for your life. I can't. Okay. All I can say is actually I can teach you, okay, what are the things you probably want to actually care a little more about. But you are your own boss. You make the decision. All right. And then there's actually no right or wrong. It's all your choice. Now there are certain ways, if you do it right, you will make your life a lot easier. Okay. This morning, I actually talking to one of my students who took my CHEM1312 last year. And he come back to me, asked me for some not advice, but opinion. Okay. I typically don't say I want to give you some advice. I typically will say I'm going to share my personal life. Okay. So that you can hear a story and then you can use that to reflect on what you're going to have for your own future. Okay. We are actually all on our own path. Okay. But I feel like certain things you can do to achieve your goal more easily. Okay. And the things I discussed with my student in the past is that, okay, he told me that, okay, he always think about things not so positively. Okay, he worry about a lot of things. He's not sure whether he can, be successful on the things he wants to work on. Okay, then I asked him, what is the benefit of thinking things passively? Okay, you want to think about the same thing. Okay, what is the benefit of that? Because that is actually things that keep us from moving forward. Okay, so if you think passively, does actually make it easier to let you get out of that difficulty? The fact is actually it won't. Okay, it won't. So since that has no effect, to help you get out of that loop and then moving toward the goal that you want to do, then why bother spend your time on that? Right? So after I said this to him, he actually think quite some time and then tell me that he cannot think of any benefit of doing that. Right? Then I tell him that, yeah, I cannot think of any benefit of that, right? I'm a person who always look at the things at the positive side, because those things motivate me a lot, right? And then keep me in a good mood. Then I know, okay, something got to change. Okay, I'm going to make some change. Okay, I want to actually improve myself by doing this, and that. Okay. At least that get me going, right? And then once you make the change, things will change accordingly. Okay, that's something that's always true. Okay, but if you don't do any change, you just stuck there, nothing's going to change. Okay. I feel like thinking passively is actually a stage that everybody needs to actually go through in your life. Okay, because we worry, right? We worry things, then you start thinking about something that is not so positive. Okay, but when you are adults, you want to actually resolve these things as soon as possible, right? Sometimes it's difficult to actually come up with this solution all by yourself. That's why you want to actually come to the lecture, right? There's someone more senior tell you some story, then you may be able to actually figure this out accordingly. Okay, so I think that's actually something that I want to share with you today, that think positively is the best way to move you forward. Okay, so I think that's actually the first lesson we want to actually have today. Then back to this. Will we get a formula sheet? Everybody know the answer? Do you have a formula sheet already? Yes, right, it's on the team side. Okay, if you don't know where the team side is, let me show you right now. Okay, I think by now everybody should be familiar with these platforms. Okay, and then on our team side, you can get Hangout for the YouTube video and also for the in-person lecture. If you go to here, you can see this in-person lecture Hangout midterm 1. So I summarize all the necessary things right here. Okay, and you can see all the recording right there. Okay, so make sure you actually get the things as soon as possible. There's only less than 2 weeks until you hit your midterm 1, right? I'm willing to help. Right, to let me. Okay, if you haven't actually watched all the videos, you actually accumulate a lot of video to watch now. Okay, so knowledge is actually something that's actually magical. Okay, it is an accumulative process. There's actually no shortcut for it, right? So if you do it little by little every day, it's easy. Okay, and the difficult one is actually you accumulate and you're trying to actually resolve it in one shot. Still doable, but they require to be super determined. And the fact is actually when you are young, we are not that determined. That's the facts, right? Now we like to try something new. That's the nature. And that's the beauty of being young. I have no problem with that. Okay. But learning, accumulate your knowledge, these things is not something you can do in that way. Okay. This is actually a truly accumulated process. So make sure you do the things little by little so you don't get burned out by doing all this study. Okay. Playing well, that's actually a way to show that you are adults. There's a way to show you to yourself that you are responsible. Okay. All the things you do, okay, to be honest, I have no right to point my finger to you. I'm not your parents. I'm not, right? I'm just a mentor. I'm just a professor who cares about students. I want to let you know how I think about things. I want to point out what are the important things in your life, not just for this course, but in your life. Okay, you can learn it, then you can actually use those concepts for the rest of your life. Those are the things I care about. Okay, I encountered many good mentors in my career. Okay, and then I feel now is actually a good time for me to really return those benefits. Okay, I think that's actually how we actually improve our community. Okay, so sometimes these things actually will be, I don't know, still actually don't feel good about the things I say. Okay, but I still need to say it because I know some of you will actually understand what I'm trying to deliver here. Okay, so hopefully majority of the class will actually get something good from me. All right, so let's actually where you can actually find your hangout, okay? Oh, this is actually very important too. Sorry, I need to go back to here. So last lecture we start to talk about, okay, I want you to start to post the questions that you don't understand in the channel, right? So for this specific week, okay, this is actually a good example. Okay, so let's actually student already post one of the questions over there. Okay, I just saw it. So I will start collecting all the things. Okay, so next week is the time we're going to go through the things that I think we need to discuss a bit deeper, so everybody will know what are the difficulties that you might have for midterm 1. All right, so starting from now, when you do your homework, if you don't understand, we have channel for every single week. Okay, so just go to the channel and post your question there. I'm going to summarize the questions, and then we're going to tell you how to solve those questions in the lecture. Okay, I really encourage everybody understand the material in the lecture, so you spend minimum of time when you step out of this door. Okay, because inside this room, you can always ask me about any questions. All right? Okie dokie. So, anything else that I need to answer? This is done. Yeah, I don't know what question number 6 is. So please post it, okay? I did not connect to Cengage. Okay, so I don't know what that question is. So if you want me to actually solve any questions, post it. Once I see the questions, I will address it, okay? You have my word. Which formula should we memorize? All the equations on this. This is the 3rd time today, huh? Would you upload the 3 sheets of all the notes? It's there already. What else would you like besides Ken? My family. I'm a family guy. I like to travel. I want to go to national park with my kids. Okay. Okay, would the hangout and quiz questions of the past chapter be a good review of the test? Yes. Okay, anything will help. But I would suggest you start from the question that I provide here. Okay, that should be the main thing you want to actually understand first. Okay, anything beyond that will be something extra. All those practice will just make you better. Okay, like I say, everything is actually accumulated. Okay, the more you do, the better you will be. I cannot understand this. I'm sorry. Oh, this is important. Okay, make sure you subscribe, please. Okay, I really want to be a YouTuber. I want to have this like 5 minutes talk. That's actually my new idea. Okay, talk about the things I feel like this, the younger students should actually know. Like the things I say this in the very beginning, right? Think positively is the way to help you to improve yourself. Okay, so I guess we'll have more like this kind of little chat in the future. Okay. Okay. What is the best piece of advice you have heard? You are going to learn those things throughout the semester. Okay. Okay. Not telling you. I do. If you go to my office, you'll see it. Can we start? Yes. All right, so I think it's actually okay. Good time to get started. Okay, so what we are going to do today is we're going to finish the so previously we actually finished the first concept, right? Defining the chemical quotient and then calculate chemical quotient for the equilibrium constant K. So we can predict whether reaction is going to move through, right? So that's actually one thing that you're going to be asked all the time. Okay, what we're going to do today is actually two things. Okay, the first one is the calculate the equilibrium constant K. Okay, the other one is ice table. So these are the two things we want to actually finish today. Okay, calculate equilibrium constant K. There are only a few principles. Okay, these are the 4 principles that you need to actually memorize. Okay. Assuming today you have equation AA plus BB that give you CC plus DD. Okay, and then if you define the chemical equation, okay, has a equilibrium constant K1. Okay, if today I flip that reaction, okay, now become CC plus DD that give you AA plus BB. This guy is going to have its own equilibrium constant called K2. And then K2 will relate to your K1 through this equation. Okay, so it's very easy to see this, okay, because you know your K1 is just C to the C's power, D to the D's power over A to the A's power, B to the B's power. That's your K1, right? And then your K2 is actually you flip your product and reactant. So now become right. So you can see you flip your numerator and denominator if you flip your chemical reaction. Okay, and those things will actually reflect by the exponent. Okay, so these are actually the first things that you need to know. Okay. Second thing, if you multiply a coefficient n for your equation, and then that will also affect your equilibrium constant K. And the way it affects it is actually your exponent needs to be actually multiplied like coefficient. Okay. Because what you do is actually your K3 is going to equals to A to the NA, B to the NB, C to the NC, D to the NC. And these can be written as A to the A, B to the B, C to the C, D to the D. To the nth power. Okay, and then you know this whole term is K negative 1 to the nth power. So it equals to K to the negative nth power. Okay, so whatever you multiply for your equation, it will be reflected at the exponent. That's the thing that you have to remember. Okay, any questions so far? Yeah, we'll see this in the example we're going to go through today. Okay. The very last things that we want to know is that if today you have two equations that has their own equilibrium constant K. Okay, so equation number 1, you have your K1. Equation number 2, you have K2. If you add up those two equations, then the new equilibrium constant will equal to K1 times K2. Okay. They say you have AA becomes CC with K1. And then BB becomes DD, you have K2. If you adding all up, then you have AA plus BB, that give you CC plus DD. Then the new K is going to equal to K1 multiply K2. Okay? And then the way you see this relationship is also very easy because you know your K1 is C to the 6th power over A to the 8th power. This is D to the D's power, B to the B's power. Your new K is simply C to the 6th power times D to the D's power over A to the 8th power times B to the D's power. This guy is this guy, right? Which is your K1. This guy is this guy, which is your K2. Okay, so if you add up two equations, then the new equilibrium constant K will simply be the product of the K1 and K2. Okay, so those are the concepts that you need to know for the first part of today's lecture. All right, any questions so far? Okay, so if not, let's go through the questions. Okay, then you will see how to apply these rules. So let's look at question number 2. Okay, let me go to this one. We have more space. Okay. Okay, so it says a certain temperature Kp is 0.25. For the reaction H2 plus Br2, that give you 2 HBr. Okay, that means actually this whole equation, you have a Kp is going to equals to 0.25. So I want you to calculate the Kp for another equation. Okay, where the new equation is, yes. So what's the difference between Kp and Kc? Pressure for the, if you use the concentration to calculate your K, that's your Kc. If you use the pressure to calculate your K, that's your Kp. And Kc and Kp can be converted. That's actually things we went through last time, right? Which is right here. Okay, that can be converted, okay, using the simple equation. Kp is equal to your Kc times RT to the delta n's power. Okay. All right, so get back to here. So what is the key word for this? Or the key features that we want to know? The key feature here is actually you are always be given a chemical equation with associated K. And then it is always going to give you a second chemical equation and X for the K. Okay, so this is actually a typical format that you need to actually use the concept we just go through. Okay, so you're going to see multiple equations and explore how the K is going to change. Okay, then we're going to use the rules that we learned to solve this problem. Okay, so how do we actually solve this? The first thing is actually you want to look at the equation that you need to solve. Okay, so if you look at this one, what is your reactant? HBr, right? The product is H2 and Br2. Now you want to compare this equation to the equation that give it to you, which is this guy, right? So what's the differences? Yeah, so you flip the reaction, right? That's one thing. That's actually another. The coefficient, how about coefficient? Divide by half, right? Okay, so you know you flip the reaction, then the new K will be, what's the rule we learned? If you flip the reaction, it becomes k to the -1, -1 power, right? Okay, and then what? You divide your equation by 2, right? Let's do it step by step. Okay, so this actually what's given. Okay, if I flip my reaction, we are going to have 2 HBr, then become H2 plus Br2. Okay, let's say I want to know the K of this reaction. I call this equilibrium constant for this equation as K1, right? So my K1 will be related to my Kp to this relationship, right? Everybody follow? Okay, so let's actually first step. Okay. The next step is actually I want to do further, right? Because the one that I really interested in is this. Right? So when you go from here to here, what happens? What is the things that you multiply? 1/2, right? You multiply 1/2. Okay. So when you multiply a certain number to the equation, then you know your new equilibrium constant will be K1 to the 1/2 of power, right? Give me some response. Okay, so you also know the K1 is Kp to the -1 power. Okay, so I just replace this with that. Therefore, you know your K2 will equals to your Kp to the -1/2 of power. Okay? And then from here, you know your Kp is 0.25 -1/2. -1, okay. .25 is actually 1/4, right? So this will become this, right? And then the square root of 4 will give you a number of. Okay. So you know for this target equation, the new equilibrium constant will simply equal to 2. Okay. But the things that you need to know is that how this target equation is related to the given equation, right? So you want to actually figure out what are the changes that you need to make. So you can apply the 3 simple relationship to get the final answer. Okay, so the 3 simple relationship is that first, if you split the chemical reactions, the new K will be the OK to the -1 power. Okay, that's rule number 1, right? Rule number 2 is that if you multiply a coefficient to your equation, then the number you multiply will go to the exponent of the new K. Okay, and the third one is actually if we have 2 equations that the new K will equal to OK, the product of the OKs, right? We haven't used that relationship here, okay? But we're going to use it for these questions. Okay, but before we dive in, any questions for the things we just went through? Okay, you're going to see these questions over and over again in your quiz, okay? So the way you should actually do is actually you start from your target equation, okay? And then compare the target equation to the equation that was given. that's given a K. Okay, then you figure out what are the changes that you need to actually make. Okay, then you'll be able to figure out what is the K values for the new target equations. Okay, so let's do another practice here. So given the value of K showing below, determine the value of K for the reaction. Okay, and then it gives you another equation with K1 and K2. Okay, so who is actually your target equation? Say I'm not continue. Yes, the first one, okay? So N2 plus O2 will give you 2NO. So that is actually equation that you want to actually get. Okay, so getting from where? From the bottom two, right? So somehow you're actually using the bottom two reactions that get back to the target equation. Okay, so the way you start it is actually you want to first identify what is your reaction, what is your product, right? And then put a reactant to the reactant side, product to the product side. Okay, so let's look at this given equation number one. N2 plus O2 give you 2NO. Okay, so you can see compared to your target equation, your N2 is actually on the reactant side, right? So this N2 is on the reactant side, which is the same as the target. O2 reactant side, which is the same as your target. NO2, you don't have NO2 for this from the first equations, right? But you know this is actually at the right orientation already. Okay, so you don't do anything with it yet. Okay. Then you go to a second equation. This equation you see, you have NO2 on the reactant side. But when you compare that to your target, the NO2 should be on the product side, right? That means you need to flip this reaction first. Okay, so you know this guy needs to be actually first do this. NO plus 1/2 of O2, that give me NO2. Then I know the new equilibrium constant will be just 3 to the -1 power, right? So that's actually the first things that you need to do. Okay. Once you make sure that this equation is actually in with the correct orientation, okay, the next thing is actually compared to your target again. Here you have 1 NO2, but your target has what? 2, right? So coefficient-wise, it doesn't agree with each other. So what you need to do is actually to multiply by 2, right? So you need to have another equation is 2NO plus O2 that give you 2NO2. And you're going to have a new K, we call it K4, which is going to equals to K3 to the, what should I put here? Second power, right? Because I multiply a factor of 2, right? So this multiplication go to your exponent, right? And then we know K3 is 3 to the negative power. So this one will be equals to 3 to the negative 2, right? Okay. So up to this point, you know this one is set. Right. I'm going to erase this so we can see it better. We know this one is set. And then this one is set. Right? So if you add up these two, equations, what do you get? You got N2 plus O2 plus 2NO plus O2 that give you 2NO plus 2NO2. Right? I just add up these things on the right-hand side with these things on the right-hand side. That's why I have on the left-hand side, right? And I add up this guy and this guy. That's the things I wrote on the right-hand side. Okay, so what I do is add up these two equations. And then we'll realize that this and that will cancel out. So that all you have is N2 plus 2O2. That's going to give you 2NO2. Right? This is actually your target. That is actually your target. Okay. So things right now I'm adding up this and this. Therefore, now I know my K should equals to K1 multiply K3. Your K1 has a value of 2. Your K3 has a value of 3 to the negative 2 power, right? So if you do this calculation, you're going to have a value of 0.222. Okay, that's actually how to get the answer of these specific questions. All right. Any questions for these two? Everybody's fine? Okay, so recap. There are three relationships, okay, to calculate the K. First one is actually if you flip the reaction, the new K is the OK to the negative 1 power. Second one, you multiply a coefficient N to your equation. The new equilibrium constant will be the O equilibrium constant to raised to the nth power. I'm running out of battery. And the third one is actually if you add up two equations, the new K will be the product of the two OKs. All right. So those are the three relationships that you should actually know. Okay. All right. So let's actually the first part that we need to know. Then we're going to talk about the second part, which will be the most important part for your midterm 1. Okay. Most of students actually get confused for this part. So the second part of today's lecture will be the ice table. Okay, so we need to actually tell you what ice table means. And then you should also get familiar with these things called the small x approximation. Okay, so this is actually the main thing we want to go through today. Okay, so you guys heard about this thing called ice table? What does I stand for? Initial, right? How about C? Change. E means equilibrium. Okay, so what it describes is that in the question you're going to encounter is going to say, okay, I'm going to put things together. Okay, they're going to start to react. Okay, so whatever they say over there is actually indicate the initial conditions of your reaction. Okay, and then once the reaction start to happen, some change is going to happen inside your reaction chamber. Okay, let's see is actually start to describe the degree of change. Okay, but eventually your reaction is going to reach the equilibrium. Then your question will tell you, okay, at equilibrium, what are the conditions that you have? Okay, so these are the three most important stage of a chemical reaction. Okay, but how do you know which stage you are at? You need to see the keywords. Okay, so what are the keywords for your initial? So these are the three keywords that you need to be very sensitive. Okay. If you see this word called Mixed. Put together. Let it react. Okay, so these are the typical keywords you are going to see in your questions. Okay, if you see these keywords is indicating, is telling the condition for the initial stage. Okay. How about change? What are the keywords you need to look for is that, okay, it's going to tell you something, let's call it something as A, okay? A is going to increase or decrease by certain amount, okay? That is actually a standard statement to tell you the change, okay? The very last one, equilibrium, you're going to see is going to say when it reach or at equilibrium. Okay, so once you see these keywords, however you say after that, it's going to describe the situation for your equilibrium. Okay, and this thing is very important because it will actually tell you where to put the information at the right position. Okay, so let's actually first thing that you need to know. Second thing that you need to know is actually this thing called a small x approximation, which you are going to use pretty much all the time when you're giving a equilibrium constant that's actually very big or very small. Okay, so when I say very big, if your k is larger than 10 to the fourth power, that's very big. If your k is very small, which indicates the condition, the k is less than 10 to the negative 4. Okay, so this has actually a huge impact when you do the calculations. What happens when you have a very large k? Do you have a lot of reactant or a lot of product? Product, okay? So when you see a k is larger than 10 to the fourth power, what you do is actually you assume all the things, all the reactants going to be converted to your product first. Okay, and only small portion of your product will actually move to your reactant. Okay, that is the time they use the small x approximation. Okay. In contrast, if you have a very small k, meaning you have very little amount of product, right? What you do is actually assume there's only very small part of your reactant is going to move to your product, okay? And then we're going to show you how to do those calculations by applying this small x approximation now. All right, so those are the concepts that we should have. Okay. Let's do some questions. So if you like this things actually more realistic. Okay, so let's go to the question number 4. Okay, so the question asks you at 700K, the reaction below has a Kp value of 54. An equilibrium mixture at this temperature was found to contain 5 atm each of H2 and I2. Calculate the pressure of HI at equilibrium. Okay, which stage this question is actually talking about? Equilibrium, right? It's actually not I, it's not C, but all the information you provide is at E. Okay, so that is actually the first thing that you need to see. Okay, so okay, so this is actually something that you have put on first. Okay, and then because we know it is actually at equilibrium, so you know whatever it says is going to belong to your E. Okay. The other information you got is what? AP here, right? So you want to know what does the KP can tell us. Okay, so here is actually a time you need to know how to write your chemical quotient or equilibrium constant equation. Okay, so you know KP is going to equals to the pressure of your HI to the second power, right? Over the pressure of your H2 to the first power, pressure of your I2 to the first power. Okay, and then the ratio between these two is going to equals to 54. Okay, make sure you know how to write the things. Okay, so pay attention to this K. This K means actually the PHI, PH2, PI2 are the pressure at equilibrium. Okay, at equilibrium, not at initial, not at change, but at equilibrium. Is that clear? Okay, so now, once you have all the things set up, now start to actually fill in this table. It tells you the pressure was found to be contains 0.5 of H2, right? So I should put 0.5 here, right? And then it said I2 is what? 0.5 here, right? It says 0.5 each for your reactant, right? So H2 and I2 should all become 0.5. All right, so what are we looking for? The pressure of what? The pressure of HI, right? So this is actually the things we are looking for, right? So far, so good. Okay. Apparently, if you can write the things out, the other information to use is this relationship, right? And then we say in this specific reaction, okay, the PHI, PH2, and PI2 are the pressure at equilibrium. Therefore, you know, PH2 is going to equals to 0.5, right? PI2 will equals to 0.05. This is the things we are looking for, right? So using this relationship, you can say the Kp is going to equals to Phi to the second power over 0.5 multiply 0.5, and this whole term should equals to 54. Okay. So with that being said, this thing was simply equals to 54 times 0.5 times 0.5. Then you take the square root of that. Okay. So by doing this, you should be able to get a value of 3.68. Okay. All right. Recap. In these questions, keyword is what? At equilibrium, right? So you know for a given chemical reaction, whatever information that provide inside this question, you need to write at the very bottom of your ICE table. Okay. And then you should also know how to write your equilibrium constant equation. Right? So in this case, it's actually H2 plus I2 that give you 2HI. So you want to know how to write this specific equation, right? And then you know this one is all going to give you a specific value, right? So you want to use this relationship in combine with the information that you got from your ICE table so that you can just solve the things that you want to solve. Yes. The point of the ice table is to let you know where you have to put the correct information. We're going to go through another 2 examples, then you will see the power of ice table. Okay. Okay, any other questions? Okay, so if not, let's actually go to do the next questions. Okay, so let's read this. Question number 5. At a given temperature, 2 ATM of H2 and 1 ATM of I2 are mixed and allowed to come to equilibrium. The equilibrium pressure of HI was found to be 1 ATM. Calculate the Kp of this reaction. Okay, a lot of description, right? Now it's the time that you can see the power of ice table. Okay. Again, write out your chemical equation first. H2 plus I2, that give you 2HI. And then write down your I, C, and E. Okay. The things you want to know is actually your Kp, right? So your Kp will define as the pressure of your Hi to the second power, your pH2, and Pi2. Okay, so this kind of setup you should have after you read through these questions. All right. Now it's actually the fun part. Okay, once you write the things out, you start going to put the information from the questions into the ice table, right? Let's read the things again. Just the first sentence. At a given temperature, 2 ATM of H2 and 1 ATM of I2 are mixed and allowed to come to equilibrium. Where should I put that number? Right? See, there's 3 keywords that tell you this is actually initial conditions, right? So we say it's actually mixed, allowed to react, put together, right? So in this case, it's actually very clear. It's mixed, right? Saying that the number you see in that sentence will go to the initial. Okay, so you have 2 H2, 1 I2. Right? After reading the first sentence, that's actually what you should do. So far, so good? Okay, then next is actually, it says the equilibrium pressure of HI found to be 1 ATM. Okay, where should I put that 1 ATM? I, C, or E? E, right? Because it says it's actually at equilibrium, right? That means it's right here. Right? And what do you want to calculate? Your Kp, right? So in order to calculate your Kp, what do you need? You need this, right? You need that. So that you can plug into the equation to calculate your Kp. Everybody follow this? Okay, so now, how do we actually go from the initial to equilibrium? We need to actually go through this change, right? But we don't have any information for the change yet. Okay, so we need to first say, assuming there's actually expulsion is going to undergo and becoming your product, right? So I put minus X for your H2, minus X for your I2. Then I'm going to put plus 2X. That give you HI. Any question for this step? Yes. Yeah, so I assume there's actually a fraction of H2. Okay, that fraction of H2, I assume is actually X. It's going to be converted into product. Okay, so I put minus X for my H2. Does that answer your question? Okay, now my question to you is actually, then why do I put minus X for my I2? Very well, right? So H2 and I2 will be consumed to form the product HI, right? And the amount you consume for your H2 and the amount you consume for your I2 should be the same, because the factors in front of your species has 1-to-1 ratio, right? That means if I use one H2, I need one I2 to produce H2 HI, right? So it's actually one H2 plus one I2 that's going to give you two HI, right? So if I consume that much, I'm going to produce 2 times of the amount for my product. Okay, coefficient matters now. Okay, so if you write minus X for your H2, you need to put minus X for your I2. You need to put plus 2X for your HI. Okay, so this is something that is very important. You need to know how to write it correctly. Yes.
What would it look like if it was like 2H2 plus 1 I2? What would it look like? Would it be minus 2X?
Okay, let's do this hypothetical questions. Okay, so let's say this is actually minus X. Okay, what am I going to put here? Very good, minus 1/2, right? You see this? What is there? Plus what? Plus X. Because the ratio between here is 1-to-1, right? Or 2-to-2, which is the same as 1-to-1. Yes. So I did not hear your question clearly. Say again. You say if that is actually the equation. If that's the equation, then you compare the coefficient ratio between here and here, then this one will become just plus X. Okay. Okay, so this is actually a very important concept that you need to be super familiar with. Okay, because many students actually get it wrong here. Okay. Everybody follow this out. Okay. Can I move on? All right. So you know that's actually a change you are going to make. Okay. And then once you reach equilibrium, what do you get? This will be you just adding up. Okay. Initial and the change. You adding up. This become 2 minus X. This become 1 minus X. How about here? No, you add up your initial and the change. Initially, you don't have any product, right? So your product is actually 0. So what do you say? We're going to have actually 0 plus 2x, right? And this thing will give you a final ratio of 1. Everybody follow this? Okay, so from here, what can you do? You can solve for your x, right? So you know your x is going to equals to 1/2, right? So this is actually the key. The question wants you to first figure out what is the x. Once you know the x, can you calculate this? 1 minus x will equals to 1/2, right? 2 minus x will be just, right? Everybody follow? Like somehow lost you guys. Yes. 0 plus 2. How do I get this? Okay, so equilibrium is actually describe the status of your reaction at equilibrium. Mathematically, it's going to equal the sum of your initial and the change. Okay, so in the very beginning, you only put your reaction in, right? And meaning you don't have any product. So I did not put anything over layer in the beginning, but it should be a 0 over layer, right? Because when you blend together, you don't have a reaction to occur yet. Therefore, you don't have any product. So the amount of product at initial should equal to 0. Okay, and then we know how to write the change. Right, we assume there's actually x fraction of your H2 going to decrease, that becomes the product. Okay, and then based on the stoichiometry in front of your chemicals, then you know that should be corresponding, that should be actually x fraction of your I2 will disappear. At the same time, you should form 2x amount of your product. Okay, and then this thing will reach equilibrium. When we say equilibrium, mathematically, what you do is actually this, add that give you the equilibrium status. Initial plus the change, that give you the equilibrium status. Initial plus change, that give you the equilibrium status. Okay, and if you look at your HI, what you have is actually 0 plus 2x. And in the questions and in your table, you know, they actually have a value of 1. Therefore, you can just solve your x. So they can just start to back calculate the pressure of your H2 and I2 at equilibrium. Yes. You mean this one? Yes, it's the same. Just the x value will be different because once you put it back to your calculation, so this is actually 210, right? When you reach equilibrium, okay, for the scenario one will be 2 minus x, 1 minus 1 half x. This will be just x. Okay. Scenario 2 will be 2 minus 2x, 1 minus x, and then 2x. Okay, so the x value will be different in scenario 1 and 2. But when you pull it back and recalculate your H2 and I2, they will give you the same value. Okay, so up to this point, okay, you can actually start to calculate the pressure of H2, I2, and HI at equilibrium. Okay, then what you do next is that you dump the things in, right? Because you know at equilibrium, your PI2, PHI is 1. PH2 is 3/2 to the first power, right? And then this one, I2 will be just 1/2 to the first power. Once you do that calculation, then you are going to get 1.333. Okay, and that's how you get the value. Okay. Any questions? Okay, if not, we want to use the remaining time to go to the very last one. Okay, so the very last one we want to go through today is this. In the reaction below, 0.5 ATN each of H2 and Br2 will place into 1 liter of flask and allowed to react. Given the Kc equals to 4, calculate the equilibrium pressure of HBr. So again, write out your equation. Okay, and then you know your K, what should we put here? Kp or Kc? Okay, look at the equation more carefully. It's all in what? Gas form, right? So when you write out the equilibrium constant for the gas, it will be Kp. Okay, so it's actually Kp, which means the pressure of your product is HBr. to the second power over the pressure of your H2, pressure of your Br2. Okay, so you want you to calculate the equilibrium. They want to know the pHBr equals to what value, right? Okay. And then in this question, it also tells you the Kc equals to 4. Okay, so those are the kind of the very first step that you want to put on your paper. Okay. And then you realize that this equation is really for the gas phase, right? But it gives you Kc. So what do? Yeah, you want to convert your case, you want to calculate your Kp from your Kc, right? So how do you do that? So what is the formula you need to memorize? So you know your Kp is equal to Kc times RT to the delta n's power, right? What is your delta n? Yeah, the coefficient difference between your reactant and product in the gas form. In the gas form. Okay, let me emphasize that again. Let's look at this equation. Tell me what is the delta n? Coefficient sum of your reactant and product. So what is the coefficient sum of your reactant? 2, right? You have 2 gas molecules on your reactant, right? How about your product? Also 2, right? What is your delta n? So delta n is the number of mole of gas molecule of your product minus number of mole of reactant. Okay, so this should be actually the total sum of that. Okay, so number of mole of gas molecule is 2, right? 2 HBr, so it's 2 mole. This is 1 mole of H2, 1 mole of Br2. So in total, 2. So it's 0, right? So whatever things to the 0th power give you a value of 1, right? So in this specific case, your Kp is going to equals to your Kc. Okay. So that is actually something that you should know. Okay. So this actual part that you should actually figure out first. Okay. So you know here is going to give you the Kp as well. Okay. All right. So once you figure it out, then go back and read these questions again. In direction below, 0.5 atm each of H2 and Br2 are placed to 1 liter of flask. Okay. Where should I put that value? The 0.5. ICOE. I, right, because they are put together, right? So you know it's 0.5 here, 0.5 here. Okay. But how are you going to use this information of K? Is that you need the information here, here, and here, right? Are we fine with this? Okay. So we say we're going to do the same thing, okay? Minus x here, minus x here. What should I put here? Plus 2x, right? So you know at equilibrium, you're going to have 0.5 minus x, 0.5 minus x. Here should be 2x, right? Okay, so every time I did not put anything, feel free to put a 0 over there. Okay, so then we know the Kp will equals to the pressure of this guy, right? Which is 2x to the second power. Your denominator will be 0.5 minus x, 0.5 minus x. Okay, so this basically becomes 2x, 0.5 minus x to the second power, and it's going to give you a value of 4. Okay, so what we can do is actually we take the square root on both sides. Therefore, we know 2x over 0.5 minus x is going to give you a value of 2. Okay, so by doing these calculations, you know 2x is going to equals to 1 minus 2x. Therefore, 4x going to equals to 1. Therefore, your x is going to equals to 0.25. All right. Once you figure out the x, okay, that is not your answer. Okay, don't feel like, okay, I figured out x, I'm so happy. No, the things we are looking for is what? The pressure of HBr at equilibrium, right? It is 2x, right? Therefore, you know your pressure of HBr to equals 2 times x, which is actually 2 times 0.25. That give you a value of 0.5. This will be actually your answer. All right. So what we're doing today is really trying to practice, okay, how to use the ice table. Okay, we did not actually give you the example of the small x approximation, but we'll give you the example next week. All right. But today is actually a very important practice that when you read the question, make sure you know where you put the value at the right location. Okay, they will actually greatly help you to actually solve the problem without any doubt. Okay, so let's say for today, thank you.